Gas laws!
Did you know that gas takes the shape and volume of containers?
Really, Bella? And do they have weak intermolecular forces?
Yes, and the volume is dependent on the temperature and pressure.
Really? And when you increase the temperature, does the pressure increase?
Yes, it does.
Isn't this a direct relationship, Bella?
Yes, it is, Scott. Yes.
In glass, all the particles are in random, straight-line paths.
Yes, and they have no attractive forces between them.
Bella, why don't you tell us about the combined gas law?
Well, Scott, temperature, volume, pressure aren't changing. The temperature must be in Kelvin. If one of the variables is constant, leave it out of the equation. Well, the equation is the P1 V1 over T1 equals P2 V2 over T2.
Bella, why don't you tell us about Boyle's law?
In Boyle's law, Scott, the relationship between pressure and volume are at a constant temperature. You can pretty much leave the temperature out of the equation since it is constant. Volume vary equals intensity with pressure, an inverse relationship. P1 V1 equals P2 V2.
Bella, why don't you tell us about Charles' law?
Well, in Charles' law, you leave the pressure out of the equation, since pressure is constant. Volume is directly proportional to the temperature, a direct relationship. Temperature must be in Kelvin.
Well, Bella, we only have 2 more laws left. Why don't you tell us about Dalton's law?
Well, in Dalton's law, Scott, the sum of the pressure exerted by each of the gases in a gas mixture is equal to the total pressure of all the gases. Total pressure equals sum of the parts. PT equals P1 plus P2 plus 3. P3. All pressures must have the same units.
Go. Well, Bella, there's one more law left, and that's your favorite one, right? The Graham's law. Why don't you tell? I'll take it.
Well, Scott, in Graham's law, gases diffuse at a different rate depending on their velocity. Velocity is dependent on mass. Lighter gases will have higher velocity, therefore will diffuse faster than heavier gases.
Well, Bella, that wraps up all the laws. But there's one more. Avogadro's hypothesis. Why don't you tell us about that, Bella?
Well, Scott, in this hypothesis, under the same conditions of temperature and pressure, equal volumes of all gas contain the same numbers of particles and the same number of moles. 1 mole equals 6.02 times 10 to the 23rd particles, and 1 mole equals 22.4 liters at STP.
Well, that's all for the folks, Bella. Thanks for explaining gas laws. That was a great episode. We'll be back next week with Gas and Friends. Now say bye. Bye.